In this video, we are going to discuss about IC555. The 555 integrated circuit timer was first introduced by Synetics Corporation, and they have two type. One is SC555 and NE555. It is available in 8-pin circular type, or it is available in as a 14-pin dual-in packages. Dual-in package means that two side I have one side I have 7 pins and other side I have 7 pins. This IC is very much popular, and it is manufactured widely. Okay, so it is very versatile, and it has a DC supply which is ranging from plus 5 volt to plus 18 volt. It's not plus or minus, sorry. This if you see SC555, it operates at the temperature from minus 55 degree Celsius to 125 degree Celsius. Therefore, it is easy to use, reliable, and low cost. If you see the monolithic IC555, it produces accurate and highly stable time delay and oscillation. Therefore, it is used in the safety alarm, timer circuits, pulse generator, traffic light controller, and it is used in one-shot and astable multivibrators, voltage regulators, oscillators, safe timer circuits, and okay. So this IC555 timer, it will provide a time delay which ranges from microseconds to hours. So now let us discuss about the pin diagram of IC555. You see, it is a 8-pin dual in-line package. So the first pin is a ground pin. Okay. The second pin is trigger. Third pin is output, and fourth pin is reset. You will see the fifth pin is my control voltage. Sixth pin is threshold. Seventh pin is discharge, and the eighth pin is my supply voltage. So this is the internal structure of functional block diagram of IC555. So here you can see the eighth pin is VCC, which is nothing but a DC power supply terminal. Okay, and the negative terminal, that is the first pin, is connected to the ground. So this ground pin is act as a common ground for all the voltage references while using the IC. Next, the output pin is third pin. You can assume it as a high level, or it can be a low level. Okay. So here I have used two comparators. One is comparator 1, that is the upper comparator, and the lower comparator, that is comparator 2. Okay. And why I name it as IC555 means you can see there are three 5 kilo ohm internal resistors which will provide a what voltage divider arrangement, right? So if you see, I have at the positive terminal of the comparator 2, I have 1/3 of VCC, right? And at the control voltage, right? At the negative pin of the comparator 1, I have 2/3 VCC, right? And I have a one flip-flop, right? It is a RS flip-flop. So you can see whenever the threshold voltage, if it is greater than the control voltage, then the comparator 1 output goes to positive saturation, right? And it will goes to 0 if the threshold voltage is less than the control voltage. Similarly, you can see if the trigger voltage is less than the positive voltage of the comparator 2, then the output goes to 1, right? So if it is greater than the positive voltage means that is plus 1, it will goes to 0. Okay, and you can see the control voltage, the fifth pin. Okay, so a control voltage is which accepts a modulation control input voltage which is applied externally, right? And here the pin 5 is connected to ground through a bypass capacitor of 0.1 microfarad. Okay, so this will bypass the noise or ripple from the power supply. Okay, you know the operation of the set and reset flip-flop, right? So if the set value is 1 and reset value is 0 means output goes to 1. If reset value is 1 and set value is 0 means output goes to 0. And if q value is 0 means q bar value is 1. Okay, so if suppose q bar value is 1 means I have connected the q bar to the base of the NPN transistor. So if the q bar value is 1 means the transistor will conduct. Okay, so the transistor will conduct. So therefore my whatever the value that is present in the 7th pin, it goes to the ground. Okay, so suppose if the q bar pin is equal to 0 means the transistor will not conduct. So the discharge pin is open circuit. Okay, now let us discuss about condition. So here you can see as I already told you, this is my threshold voltage, control voltage, trigger, discharge pin, and reset, right? So if the threshold pin and the trigger pin, if both the values are below the 2/3 VCC, the threshold voltage is below 2/3 VCC and trigger value is below 1/3 VCC. Okay, so you can see so if it is below means the comparator 2 value goes to 1 and comparator 1 value, since it is below 2/3 value, it goes to 0. So my output goes to 1, and if the discharge pin q bar is 0 means the discharge pin get open circuit, right? So the output goes high here. Next one, if it is above the 2/3 value and above the 1/3 VCC. If that is the case, it will be opposite, right? So it will be 1 0. So my output q goes to 0 and q bar goes to 1. So if it is 1 means the discharge pin get short circuited, right? So the output goes to low and discharge pin goes to ground. So if the threshold pin is above 2/3 VCC and trigger pin is below 1/3 VCC means it will be remain as similar to the last state. Okay, if the threshold voltage is below 2/3 VCC and above 1/3 VCC also, it will be in the last state.